We know that atoms can either share, gain, or lose electrons to have a stable octet structure, which means they should have 8 electrons in their last shell. Now, compounds which are formed by gaining or losing of electrons are called as ionic compounds. But the compounds which are formed by sharing of electrons are called as covalent compounds. Let us see the difference between ionic and covalent bonding. Covalent bonds are formed by sharing of electrons and ionic bonds are formed by exchange of electrons. Covalent bonds have low melting and boiling points while ionic compounds have high melting and boiling points. This is because there is a stronger force of attraction between molecules of ionic compounds. Covalent bond is formed between two nonmetals and ionic bond is formed between a metal and a nonmetal. Covalent compounds are usually non-polar and ionic compounds are polar. Ionic compounds conduct electricity while covalent compounds do not. We know that the carbon has an atomic number of 6 and its electronic configuration will be 2, 4. To be stable and form octet, carbon either has to gain 4 electrons or lose 4 electrons. But both are very difficult. If carbon gains 4 electrons and becomes carbon 4 negative, then it would be difficult for the nucleus with 6 protons to hold on 10 electrons. On the other hand, if the carbon loses 4 electrons, it becomes carbon 4 plus. But a large amount of energy is required to remove 4 electrons. So carbon shares electrons to form bonds. In other words, carbon forms covalent bonds by sharing electrons with other atoms. Since carbon has 4 electrons in its outermost shell, it can share 4 electrons and hence its valence is 4. So carbon is tetravalent. Let us understand covalent bonding by taking the example of hydrogen. Hydrogen has only one electron, which means it needs one more to form a stable octet. So two hydrogen atoms will share the electrons to form an hydrogen molecule. Since both of them are sharing electrons, both of them have 2 electrons and have an electronic configuration of helium. Since they are sharing a pair of electrons, there is a single bond between them. This is the electron dot structure of hydrogen molecule. Now the two dots represents one electron each of each atom. Now let us try to understand the covalent bonding in oxygen. Its electronic configuration is 2, 6. It needs 2 electrons to attain octet configuration, that is 2, 8. So two oxygen atoms share 2 electrons each. Now we can see that both oxygen atoms have 8 electrons in its outermost shell as a 2 pairs of shared electrons, that is 4 electrons belong to both the atoms. Thus, oxygen attains stable octet configuration. Since 2 pairs of electrons are shared, there are 2 bonds between oxygen atoms. In the case of nitrogen, which has an electronic configuration of 2, 5, it requires 3 electrons to attain stable octet. This is done by sharing 3 pairs of electrons as shown. Now both the atoms of nitrogen has 8 electrons each in the outermost shell, thus attaining the octet. Since 3 pairs of electrons are shared, there are 3 bonds between the nitrogen atoms. Water molecule also contains covalent bond. It is formed by oxygen, which shares a pair of electrons with each of the hydrogen atoms. As a result, oxygen has 8 electrons in its outermost shell and 2 hydrogen atoms have 2 electrons each, thus attaining a stable state. Similarly, in the case of ammonia, which is NH3, nitrogen shares a pair of electrons with 3 hydrogen atoms. Thus, nitrogen attains a stable configuration of 8 electrons in its outermost shell and hydrogen has 2 electrons in its outermost shell. In the case of methane, which is CH4, similar sharing is seen. Carbon that needs 4 electrons share 1 electron each with 4 hydrogen atoms. Thus all the atoms attain a stable octet. This phenomena in which an element exists in more than one forms having different physical properties but identical chemical properties is called as allotropy. Carbon has 3 allotropes in the crystalline form. These are diamond, graphite and fullerene. All of them have similar chemical properties, but the difference lies in the manner of the structure of bonding of carbon. So we are going to see the different allotropes one by one. Diamond has a rigid 3-dimensional structure and graphite has 2-dimensional sheet-like structure which lies one above the other. Diamond is the hardest substance known, whereas graphite is soft and greasy, which makes it useful as a lubricant in heavy machineries working at high temperature. Diamond is a bad conductor of electricity, but a good conductor of heat and is used in cutting tools. Whereas on graphite is a good conductor of heat and electricity. It is used in making electrodes of the battery. Diamond is transparent and has highest refractive index, so it is used in gemstones and jewelry. Graphite is an opaque grayish substance. Diamond is chemically inactive while graphite is highly reactive. The third type of allotrope is fullerene. It's spheroidal in shape and contains even number of carbon atoms ranging from 60 to 350. The first one to be identified was carbon 60, which has the shape of a football. Since it looked like a geodesic dome designed by US architect Buckminster Fuller, it was named as fullerene. Now let us see the chemical properties of the carbon compounds. The first property which we are going to see is combustion. The burning of carbon compounds in the presence of oxygen to give carbon dioxide, water and heat is called as combustion. You can see the chemical equation of combustion of carbon, methane and ethanol here. You can try to balance this equation based on what you have learned in the first chapter. You might have seen burning of LPG on your stove. What is its color? It's usually blue. This is because of the complete combustion of LPG, which is mostly butane. But you might have observed at times that the flame turns yellow. This is because incomplete combustion of LPG caused due to insufficient supply of oxygen. This also results in the formation of soot, which blackens the bottom of the vessels. The flame of the candle is always yellow. This is because wax, which is a fuel for burning candle, is unsaturated hydrocarbon, which results in the incomplete combustion. Unsaturated hydrocarbons never get enough supply of oxygen and almost always generate soot. Carbon is a reactive element and its compounds can oxidize themselves during the combustion process. But there are other types of oxidation as well. Alcohols in the presence of alkaline potassium permanganate or acidified potassium dichromate oxidize or add atoms to form carboxylic acids. Potassium permanganate and potassium dichromate are called oxidizing agents. Addition reaction is a reaction where one molecule gets added to another molecule. Hydrogen gets added to unsaturated hydrocarbons in the presence of a catalyst like nickel to form unsaturated hydrocarbons. You can see that hydrogen gets added to unsaturated hydrocarbon. Vegetable oils generally have long unsaturated carbon chains while animal fat has long saturated carbon chain. Vegetable oils which are unsaturated are healthier and should be used in cooking. Substitution reaction is a reaction in which an an atom or a group of atoms is substituted by another. Though saturated hydrocarbons are fairly unreactive, in the presence of sunlight, chlorine replaces or substitutes hydrogen to form chloromethane. Now let us learn about one of the hydrocarbons, ethanol. It's colorless liquid with ethereal, faint smell and a burning taste. Its molecular formula is C2H5OH, and this is its structural formula, where OH group is attached to C2H5 group. This is used in making alcoholic drinks. It is also used as a solvent in medicines like tincture of iodine, cough syrups and many tonics. It's soluble in water in all proportions. Consumption of pure ethanol can be lethal. Consumption of dilute ethanol, though a widespread practice, is not good for health. Ethanol reacts with sodium to form sodium ethoxide and liberating hydrogen gas. On heating ethanol at 443 Kelvin with the excess of concentrated sulfuric acid results in dehydration of ethanol to give ethene and water. Here, concentrated sulfuric acid is the dehydrating agent. Now let us study another organic compound, ethanoic acid or acetic acid. It belongs to a group of compounds called as carboxylic acids. As the name suggests, they are acidic, but unlike acids like HCl, they are weak acids. 5 to 8% solution of acetic acid is called as vinegar, which is widely used in cooking and in preservatives. The melting point of pure acetic acid is 290 K, so it freezes during winter. Frozen acetic acid is called as glacial acetic acid. Its molecular formula is CH3COOH and its structural formula is this. Ethanoic acid reacts with alcohol in the presence of an acid catalyst to form esters. This reaction is called as esterification reaction. Esters smell sweet and are used in flavoring agents are called as perfumes. Esters, on treating with sodium hydroxide, convert back to alcohol and sodium salts of carboxylic acid. This reaction is called as saponification. Ethanoic acid, which is an acid, reacts with the base, say sodium hydroxide, to form salt and water. The salt in this case is sodium acetate. Ethanoic acid also reacts with carbonates and hydrogen carbonates to form salt, water and carbon dioxide. The salt produced in this reaction with sodium hydroxide is sodium acetate. Let us learn what are soaps and detergents and how do they work. The dirt is oily in nature and the oil does not dissolve in water. So we need external cleansing agents like soaps and detergents. A molecule of soap is a sodium salt of long chain carboxylic acids. It has a hydrophobic end and a hydrophilic end. The hydrophilic end is ionic end, which dissolves in water, while hydrophobic end dissolves in oil and dirt. When we apply soap to a certain stain of oil or grease in the clothes, the hydrophobic end gets attached to the oil and the hydrophilic end dissolves in water. And sometimes many molecules get attached in a similar way to form a cluster of molecules in which the hydrophobic end is in the interior of the cluster, which is near to the dirt, and the hydrophilic end is on the surface with the water. This leads to the formation of micelles. They do not form insoluble salts due to ion-ion repulsion. This is why rinsing of clothes with water, the stains along with the micelles get removed. Soap micelles are large enough to scatter light, hence soap solution appears cloudy. You must also have noticed that sometimes when you apply soap while taking bath, foam is formed with difficulty and there is a formation of insoluble precipitate or scum. This is due to the reaction of soap with calcium and magnesium salts which are present in water.
These salts cause hardness in water. This problem is overcome by using detergents. Detergents are ammonium or sulfonate salts of long chain carboxylic acids. These compounds do not form insoluble precipitates with calcium and magnesium salts and hence can be used in hard water as well. They are usually used in making shampoos and products that clean clothes.